Okay, so this video is the final video in our quadratic algebra series or topic, and we're looking here at how to solve quadratic equations using something called the quadratic formula. So the quadratic formula is a rule or a formula that we get when we solve the most general quadratic equation using completing the square. Okay, so this is where I was saying to you in the previous video when we're using completing the square to solve a quadratic equation, I would never do that because we have a formula that does that for us. It's called the quadratic formula. So if I have a quadratic equation where the quadratic doesn't factorize and so I can't use the null factor law, my next step is going to be to use the quadratic formula. And so I wouldn't complete the square. I wouldn't use completing the square as a solving method. It has plenty of other needs and we absolutely need to know how to do it, but I would bypass that process and use the quadratic formula. So I'm going to, off to the side here, show you where this formula comes from. You don't need to be able to replicate this, but I think you should be able to follow the algebra of this. So as I said, if we solve ax squared plus bx equals c by completing the square, we get our quadratic formula. So let's have a look at how to do that. I'll just scroll over to the side here. So if the question is to solve ax squared plus bx plus c equals 0. So this is the most general quadratic. This means for any quadratic trinomial, a is 1, b is 2, c is 3, a is 1, b is 3, c is 0, a is 7, b is -1, c is 2, whatever. We should be able to solve the quadratic using this formula that we're going to generate just by starting with this most general form. Okay, so we're going to do that by solving using completing the square. So we want to focus first of all on completing the square on the left-hand side. And we all know that the first step in completing the square is that we can only complete the square for monic quadratics. So the first thing we need to deal with is the fact that we have ax squared here. And so I'm going to, because I've got an equation, so I'm equal to 0, I don't need to factor out the a, I can just divide the whole equation by a. So this is going to be x squared plus b divided by ax plus c divided by a. Okay, so that's our first issue. So now we want to focus on completing the square. So we know that when we complete the square, we focus on the first two terms and we work out what do we need to add in and take away so that we can make a perfect square. And we know that the process for completing the square is to focus on this coefficient of x, which is positive b over a, and look at halving and squaring that. Okay, so let's think about that. So if we have b over a and we want to halve it, so that's divide it by 2 or times it by a half, okay, that's going to give us b over 2a, so that's half of b over a. And then we want to square that, so we're going to get b over 2a all squared, which will be b squared over 4a squared. Okay, so let's pop that in. That's what we're going to need to add in to make the perfect square. So we're going to have b squared over 4a squared. We're adding that in, and now what we have there is a perfect square. And obviously we can't just add that in because we feel like it. We've now changed the equation, so we also need to take it away. Or you could add it onto the right hand side, but I'm going to take it away. Okay, so the first three terms now form my perfect square. Okay, and we know that the perfect square, we take the coefficient of x and we halve it, to go in the perfect square. So we're going to have x plus, because there's a plus there, b over 2a, which is half of b over a. We just did that over here. Okay, so then out on the right hand side here, I've got two terms. What I'm actually going to do here, I think, before, there's a few different ways in which we could do this. I'm going to add those onto the other side of the equation. Okay, so I'm going to add b squared on 4a squared. So I'm going to have b squared on 4a squared on the right hand side, and I'm going to need to subtract c on a. Okay, because remember we're trying to solve for x, and now that we've completed the square, we've just got x in that one place there, so we're focused on getting that on its own. Okay, before I focus on square rooting and etc., I'm just going to tidy up the right hand side a little bit. So we've got x plus b over 2a all squared equals, let's get a common denominator here. So b squared over 4a squared minus, now we want to write this over 4a squared as well, which means we've multiplied the denominator by 4a, and so we need to do the same to the numerator. So we'll have 4ac on the numerator. Okay, now we can combine that together as one fraction, b squared minus 4ac all over 4a squared. Okay, so now let's focus on that's all equal to x plus b over 2a squared. So let's take the square root at this point. So remember, when we take the square root, we need to be careful about the fact that we get a positive or negative square root. So x plus b over 2a is positive or negative square root of b squared minus 4ac all over 4a squared. Now that denominator is a nice perfect square, so actually we could just look at square root of b squared minus 4ac on the numerator, all divided by the square root of 4a squared is 2a. Okay, so now we've got x plus b over 2a equals positive or negative square root of b squared minus 4ac all over 2a. And then we're going to, lastly, to get x on its own, subtract b over 2a. And remember, I usually write that in front of the square root just to avoid any ambiguity about where it goes. And we've got a nice common denominator here, so we find that x is negative b plus or minus square root of b squared minus 4ac all over 2a. And there we have our quadratic formula. That is the solution or the solutions to the equation ax squared plus bx plus c equals 0. Okay, so if, for example, you're trying to solve the equation, I don't know, 2x squared plus x minus 3 equals 5, you can't let a equal 2, b equal 1, and c equal negative 3, because there's this over here. So you would first of all need to subtract the 5, that would make that negative 8, so it's equal to 0, and so then c is negative 8. There's your a value and your b value and your c value. You put them into your quadratic formula and you've got your answer to the equation. Okay. Now, I'd still stand by, if it's a quadratic that will factorise, that's quicker. Okay, this formula can get a bit ugly with the surds and the fractions, and there can be a bit of simplification required there. And so if your quadratic will factorise, that's still your best method for solving. If it will not factorise, I wouldn't bother with completing the square. I would go straight here to your quadratic formula. Okay. All right, so that formula is written up here in your notes. Oh, sorry. Got us lost in the middle of the OneNote file. Here we go. Okay, so we've got the quadratic formula given here. This is a formula that you need to learn. Okay, this is a formula that will come up often enough that you will need to know. It'll come up in the context of other things, not just when you're studying quadratics. Okay, so it's something you need to kind of learn. And it is a formula that in the next couple of years, when you go on to do maths methods in VCE, it is not a formula you get provided on a formula sheet, and yet it is something you will need to be able to execute. So I encourage you to really focus on sort of memorising and learning this formula. I don't usually like to suggest memorisation as the strategy, but this is one that it's worth investing the time into memorising. Okay, so let's solve each of the following equations using the quadratic formula. Okay, now the first one out of interest does factorise, and so my recommendation would be that you would factorise it, but let's see how that's going to look when we use the quadratic formula. And we'll end up with whole number answers that don't have the surd. And if you end up with whole number answers, it means that your equation would have factorised and that you probably could have done it more efficiently. Okay, so the key thing is to make sure you've got your ax squared plus bx plus c equals 0 form before you start completing the square. From there you can then identify your a value here is 2, your b value here is 3, and your c value here is 1. Careful about signs. This is positive 3, this is positive 1, this is positive 2. Okay. And then where our solutions then are going to be x equals, let's not forget about the x equals, okay? The solution to an equation isn't just a number, it's, in this case, because the equation has x in it, should be x equals something. Okay, so x will be equal to negative b, so if b is 3, that'll be negative 3, plus or minus the square root of, now b squared, which is 9, minus 4 times a, which is 2, and times c, which is 1. And then we're going to have all of that divided by 2 lots of a, so that's 2 times 2. Alright, I might, so just so we can see the formula, I might just write that out as 3 squared for this first step. You can by all means simplify as you go as much as you want. I just want to be clear about where each of those numbers is going to and what coming from and going to and why. Okay, so we're going to have negative 3 plus or minus. Let's simplify what's under the square root. So we're going to have 9 minus 8 there, because 4 times 2 times 1 is 8. So that's going to be 1. And then we've got all that over 2 times 2, which is 4. Okay, square root of 1, 1's a square number. Square root of 1 is 1. So this is negative 3 plus or minus 1 over 4. Now that won't usually happen. Usually you'll still have a third, because if that does happen, it's because you could have factorised it and you shouldn't really be getting to this point. Okay, so there's our two solutions. Now we haven't finished. You can't leave that because you can actually simplify. If that was a third, we wouldn't necessarily be able to simplify it any further, but we can work out what negative 3 minus 1 and negative 3 plus 1 is, so we need to do that. So this is two separate solutions, negative 3 minus 1 over 4, or negative 3 plus 1 over 4. Negative 3 minus 1 is minus 4, that's negative 2, and so we get negative 1 or negative 1/2 are our solutions for x. Okay. As I said, the fact that they are answers that don't involve surds means that the original quadratic would have factorised, and in fact that's probably the better process. Okay, let's have a look at another example. So in this instance, again, we've got ax squared plus bx plus c, so our x squared term, our x term, and then our constant term equal to 0. So we're in the right form. We want to focus on what a and b and c are. So when we just have x squared, it's not 0x squared, it's 1x squared. So that means a is 1, b is 4, positive 4, and c in this case is negative 2. Careful of the negatives. Okay, so then we can substitute into our formula. So x, the solutions to this equation are going to be equal to negative b. So b is currently 4, so negative 4, plus or minus square root of b squared, so 4 squared, minus 4 times a times c, which is negative 2. So careful of the negatives, that's where you'll make mistakes. All divided by 2a. Okay, so we've got negative 4 plus or minus the square root of, now that's going to be 16, and then we're going to have plus 8 all over 2. So we've got negative 4 plus or minus the square root of 24 all over 2. Okay, so we can't stop there. Then once we've sort of initially simplified our quadratic formula to this point, we then need to look for two things that we might be able to simplify further. The first is whether or not we can simplify the surd, okay? And then the second, which we'll look at after we've simplified the surd, will be whether or not we can simplify the fraction. Okay, so in this case the surd will simplify. So simplifying surds we should be pretty comfortable with now. We're looking for square numbers that go into 24, and that's 4. So root 24 we know is root 4 times 6, and so that's going to be 2 root 6. Okay, so this is 2 root 6 over 2. Okay, then we want to see whether there is any common factors in the fraction. Okay, so in this instance we've got 2 as a common factor. Oh, sorry. Now if you want, you can write out the line where you factor out the 2, so it's going to be negative 2 plus minus root 6 all over 2, and then cancel out the 2, because that's the only way you can cancel. Remember, you can't just, cancel with that and not also cancel with the other part of the numerator. So please be careful about that process of cancellation again. But equally, the other way that you can sort of think about it, and normally I use my hands to cover things up here, so let me just see if I can show you what I mean, is this is basically two fractions in one. This is negative 4 on 2 plus or minus 2 root 6 on 2. Okay, so I wouldn't actually write out this next line, but this is what I'm really thinking about in my head. You've got negative 4 on 2 plus or minus 2 root 6 on 2, and both of those fractions will simplify, which is why I need to go to this next step. If only one of those fractions would simplify, you don't need to go to this point. Okay, but because 2 is common to both of them, I'm going to end up with negative 2 plus or minus root 6 as my solutions. So there's my two my two solutions to the equation, negative 2 plus root 6 or negative 2 minus root 6. So two numbers. We can't simplify negative 2 plus root 6 or negative 2 minus root 6. They're not like terms. So that's in simplest form, and they are our solutions. And so this is a quadratic that wouldn't have factorised. Factors of negative 2 that add up to positive 4, there aren't any. That doesn't mean there aren't solutions to the quadratic. We then need to go to the quadratic formula. It's just that the solutions are irrational, which is why we couldn't find them using the process of factorisation. Okay, two more examples here. So again, let's identify, they're both in the right form. Let's identify our A and our B and our C values. So A is 4, B is negative 12, and C is 9. Now actually, again, this is a quadratic that factorises, and you might actually recognise that this is a perfect square. But I want to use this as an example to show what might happen in the quadratic formula in this particular instance. But equally, if you recognise the perfect square, factorise it and solve it that way. You shouldn't need the quadratic formula. Okay, so x is equal to negative b, so negative negative 12, that will be positive 12, plus or minus square root of b squared, now negative 12 squared is 144, minus 4 times a, which is 4, and times c, which is 9, all over 2 times a, which is 2 times 4. Okay, so we're going to get 12 plus or minus square root of 144, take away. Now let's see, you could do this as 4 times 4 is 16, and then 16 times 9, or you might do 4 times 9 is 36, and then do 36 times 4, whichever way is more comfortable for you. You might go with 16 times 9. 16 times 10 is 160, so 16 times 9 is 160, take away 16, which is 144, all over 8. Alright, so we've actually here got 12 plus or minus the square root of 0 over 8. So square root of 0 is just 0. Plus or minus 0 is not doing anything at all. So we've really just got 12 over 8. Here is our solution. That's a fraction, not in simplest form, common factor of 4. So that leaves us with 3 over 2. So there's just the one solution to that equation. It is a rational solution, doesn't have any surds in it, so actually we could and should have obtained that solution using factorisation and the null factor law rather than needing to go to the quadratic formula. Okay, part D, quadratic trinomial, it's in the right form, it's equal to 0, so A is equal to 4, B is equal to negative 6, and C is equal to positive 3. And so x is going to be negative b, so negative negative 6 is 6, plus or minus square root of b squared, negative 6 all squared is 36, minus 4 times a, which is 4, and times c, which is 3, all divided by 2 times a, so 2 times 4. Alright, we've got 6 plus or minus the square root of 36 minus, now 4 times 4 is 16, and 16 times 3, or you might have done 4 times 3, which is 12, and 12 times 4, either way, it's 48 over 8. So we get 6 plus or minus the square root of, now 36 minus 48 is negative 12 over 8. And we've hit a problem. Okay, it's not possible to take the square root of a negative number, and so therefore this expression we've got here doesn't actually exist, and so therefore this equation actually has no solutions. So remember, quadratic equations might have two solutions, as we saw in the first two examples up here, or they might have one solution, as we saw in part C, or they might have no solutions, as we can see in part D. When we have two solutions, they might be irrational solutions, which is what we're seeing in part B over here. Okay, they involve surds, or they might be rational solutions. If they're rational solutions, the quadratic would have factorised, and we should have really factorised it at the beginning. Okay, if they're irrational solutions, we're going to be able to find them using the quadratic formula. Okay, so I presented sort of three different situations here where we get, or four different situations, sorry, where we get two solutions, rational or irrational, where we get one solution, where we get no solutions. So I want to actually have a look at, there's an important part of the quadratic formula that gets its own name because it actually allows us to determine things about the quadratic equation, and when we think about quadratic graphs next semester, it allows us to determine things about the quadratic graphs as well. And that's actually the part underneath the square root here. So that is this part here. We call that the discriminant, and we denote it with that triangle, which is the capital Greek letter delta. And so we call the discriminant b squared, we call b squared minus 4ac the discriminant, and it tells us a bit about the solutions of the quadratic. Let's have a think about what happened up here when we had our different options here. So here in part D, we found that the discriminant was equal to -12. And when that happened, it meant we were trying to square root a negative and therefore there weren't any solutions. In part C, we found that the discriminant was equal to 0. And when that happened, we end up with plus or minus 0, and we actually just end up with the one solution because the whole half of the fraction to do with the square root just completely sort of disappears, and we essentially just end up with -b on 2a, which happened to be 12 over 8 in this particular case. And so we just get that one solution when that happens. And then in these two examples, in both instances, we had the square root of a positive number. Okay. Now, if the positive number was a square number, it meant that we got rational solutions, solutions that didn't involve surds. That's what happened in part A. And if the positive number was not a square number, 24 is not a square number, we got irrational solutions because our answer still has a surd involved with it. Okay. So those are the different things that could happen. All right. So if our discriminant ends up being negative, that means we've got a negative number under here. And so therefore that whole thing becomes a problem. It's not just that we ignore it, it actually is problematic, it doesn't exist, and so that means that the quadratic equation doesn't have any solutions. So if b squared minus 4ac is negative, that tells us that ax squared plus bx plus c equals 0 doesn't have solutions. Any real solution, okay, technically speaking. So that it is possible to get a non-real or an imaginary solution, but that's something you will look at in specialist maths and above only. For our intents and purposes, in terms of the real number system, which is what we work in, there is no solution. But technically speaking, we would say it doesn't have there's no real solution. Okay, what would happen if the discriminant was 0? Okay, so if the discriminant was 0, that's when we would end up with, our solutions equaling -b plus or minus the square root of 0 all over 2a. And this whole thing is just 0, and so we just get -b over 2a. So we just get the one solution, because the only reason we get two solutions is this plus and minus happening in here. And that goes away if b is 0. If the discriminant is 0. And so we know that ax squared plus bx plus c equals 0 has one real solution, and that real solution is x equals -b over 2a, okay, because the plus minus square root section disappears if the discriminant is 0. And the third thing is that if the discriminant is something positive, okay, then we have -b plus or minus the square root of something positive in here, and so there we can get we get both a positive and a negative square root if there's a positive number under there, and so that's when we're going to have two solutions. Okay, ax squared plus bx plus c equals 0 has two real solutions. Okay. The other thing to note is that if the discriminant is a square number, so that is 1, 4, 9, 16, etc., then the equation has two rational solutions. So not irrational. They won't involve surds. And you should have factorized. You shouldn't have got to this point. Have factorized to solve. Factorized. Sorry. Okay. So in example 2 here, we want to use the discriminant to determine how many solutions each of the following equations will have. Where there are solutions, so if there is one or two solutions, then we want to go on and find those solutions. And this can actually be a good way to use the quadratic formula, because it means if there aren't any solutions, you don't go any further. So a good way to use the quadratic formula is to calculate your discriminant first, b squared minus 4ac. So in this first example, a is 4, b is 7, and c is 5. They're all positive. And so we're going to get 7 squared minus 4 times 4 times 5. So we get 49 minus Now I might do 4 times 5 first, that's 20, and 4 times 20 is 80, 49 minus 80, whatever that is, it's negative, it doesn't really matter. What is it, negative 31? Okay, so therefore we get no solutions since our discriminant is less than 0. We have a negative discriminant. Okay, so we don't need to go on and find those solutions in this instance. There's no point. Okay, discriminant, well, it's not that there's no point, it's that it's not even possible. Discriminant in this case, b squared minus 4ac. So the discriminant doesn't involve the square root. The discriminant is just a bit under the square root. Sometimes students have a tendency to tell me that the discriminant is equal to the square root of b squared minus 4ac, but it's just equal to b squared minus 4ac. In this instance, b is negative 8, so we can have negative 8 squared minus 4 times a, which is 3, and times c, which is 1. Okay, so negative 8 all squared is positive 64, and then we've got minus 12. So subtracting 12 from 64 gives us 52. And so that means since our discriminant is bigger than 0, it's positive, the equation has two solutions, two real solutions. Okay, so we know there's two solutions and now we want to find them. So let's find those solutions. So we know x is equal to negative b plus or minus the square root of our discriminant. We've already done the hard work to work that bit out, over 2a. So in this equation, negative b, negative negative 8, positive 8, plus or minus the square root of our discriminant's 52, all over 2a, so 2 times 3, which is 6. Okay, let's simplify the third. So root 52 is, root 52 is 4 times 13. Those of you that are familiar with a deck of cards will know that 52 cards, 4 suits of 13 cards. So root 4 times root 13 is 2 root 13. Okay, so we're going to have 8 plus or minus 2 root 13 over 6. Okay, so we've simplified the third, and now we want to focus on simplifying the fraction. Now there's a common factor of 2 in all of those numbers. We've got 8, 2 and 6. 2 is the highest common factor in everything there, so we want to divide everything out by 2. We're going to have 4 plus or minus root 13 over 3. And there is our two solutions, x plus root 13 divided by 3, and 4 plus root 13 divided by 3, and 4 minus root 13 divided by 3. So there's our two solutions to that equation. So as we've seen here, it could be useful to think about calculating the discriminant b squared minus 4ac first, because even if there are solutions, all you've done is save yourself a bit of energy and allows you to go sort of straight to this point down here. And so it's calculations you'd need to do anyway. So find it first. If it's negative, you don't need to go any further. There aren't solutions. If it's positive, then you stick it straight into your quadratic formula and simplify your answer. Now, the other thing I again want to reiterate is that this method should be used as a last resort if your quadratic doesn't factorize. I'm just going to, before I finish off this video, I'm just going to move across to one other page in this document. That I want to include this sort of summary document of the process that needs to happen in your head when you're faced with a quadratic equation, okay? Because it's very easy when we're studying quadratic equations to treat each quadratic separately and just think, oh, well, today's lesson's on the null factor law, so I'm going to solve them all by doing the null factor law. Oh, today's lesson, we're completing the square, I'm going to solve them all by completing the square. Oh, today's lesson's on the quadratic formula, we're going to use the quadratic formula. Whereas in reality, the question will say, solve this quadratic, or solve this equation even. And first of all, you need to recognize it as a quadratic equation. Then you need to decide which method is the best method. So this is the sort of decision process that should be happening in your head. So the first decision is it a quadratic equation? Does it have a highest power of, is the highest power of x equal to 2? Okay. The next decision is, do we have only one instance of x? So maybe we have something like x squared equals 5. Maybe we have x squared minus 8 equals 0. Maybe we have x plus 2 all squared equals 4. Maybe we have x minus 1 all squared plus 8 equals 0. Okay? Do we have just one x in the equation? And if we do, we want to solve it by rearrangement. Don't make it any harder than it needs to be. That's the simplest thing. You could give any of those equations to a Year 7 student and they can do the same thing to both sides and solve for x. Okay, so you want to think about that first. Can I solve this by rearrangement? That's your first question. Yes, do it. No, okay. So, and the answer will be no if your quadratic has both an x squared and an x term. So if your quadratic is x squared plus x equals 0, or if it's x squared minus 2x plus 4 equals 0. So if you've got two terms involving x that are not like terms, you won't be able to solve by rearrangement. Okay, so then once you've identified that, you need to make one side of your equation 0. The next thing is to divide the equation by any numeric common factors. So if you've got the equation 3x squared minus 6x plus 12, don't make it a harder quadratic. Divide everything by 3 and make this x squared minus 2x plus 4, and then solve that. Okay, so divide away any numeric common factors. Then you're going to need to factorize. Okay, now if you've got two terms, it might be, it's probably you're just going to need to take out a common factor. If you've got three terms and it's a simple quadratic, so by simple I mean monic, so 1x squared plus bx plus c. Then you use your simple factorization process, factors of the constant term that sum to give the coefficient of x, and write those numbers straight in the two brackets. If it's a harder quadratic, meaning a non-monic quadratic, ax squared plus bx plus c, and that a is not a common factor, okay, then you're going to need to use your harder factorization process. So you multiply the coefficient of x squared by the constant term, a times c, you look for factors of that number that sum to the coefficient of x, so that sum to give b, and you rewrite the x term using these numbers, and then you factorize by grouping. If it won't factorize, so once we use, if it will factorize, then we use the null factor law to solve, okay? If it won't factorize, then we use the quadratic formula, okay? Solve by rearrangement if you can, factorize a null factor law if you can. If all that fails, quadratic formula is your way to go. Okay, there's some work for you today focused on quadratic formula, and then there'll be some work in the next couple of lessons with more general, here's some quadratic equations, solve them, and needing to make those decisions along the way.